conformal transformation. Conformal transformation in complex variables, complex functions. Suppose, see the definition of conformal transformation. Suppose two curves are there. Let me write first definition. Suppose two curves C1 and C2 in Z plane. Two curves C1 and C2 in Z plane intersect at a point. Intersect at a point capital P, and the corresponding curves say C1 dash, C2 dash, corresponding curves C1 dash and C2 dash in the W plane. In the W plane, intersect at P dash. Intersect at P dash. Under the transformation, W equal to f of z. Under the transformation, W equal to f of z. Okay, so what is the thing here? See, let me draw the figure roughly. This is Z plane. Z plane means which contains the variables x and y. The variables x and y. This is one curve C1 and this is another curve C2. C1 and C2, these two are intersecting at point P. Okay, these two are. And coming to W plane, let me draw. This is W plane. W plane means what? Already I told you. See, W equal to f of z means what? W means what? U plus iv. F of z means what? F of x plus iy. So W equal to f of z means what? It is a complex function, and it also gives a mapping from z plane, that is xy coordinate system, to uv coordinate system. This is u and this is v. This is v. For example, with respect to the function w equal to f of z, this is C1 curve, C1 dash, image of C1. And this is some C2 curve, C2 dash, image of C2. And this is the intersecting point P dash. This is the intersecting point P dash. Here, the angle is theta. The angle is theta. Here, the angle is between these two. This is theta dash. This is theta dash. Got it? And how I can represent W equal to f of z as a transformation? Let us see. Let me complete the definition first. If the angle of intersection of the curves, angle of intersection of the curves at P is the same as the angle of intersection of the curves at P dash, both in magnitude and sense. Both in magnitude and sense. What is the meaning of this? If angle at P is, for example, 30 degrees, at P dash also 30 degrees, and sense means rotation of the curves anti-clockwise, angle rotation anti-clockwise direction, that is called sense. Okay, sense, then both are same, both in magnitude and sense the angle is same, then the transformation is called, what is the transformation or the function? W equal to f of z is called conformal, mapping, is called conformal transformation or mapping. Conformal transformation or conformal mapping, or this is also called as Mobius transformation. This is also named as Mobius transformation. Okay, Mobius transformation. This is the definition of conformal transformation. Okay. And for example, if angle is both angle at P and P dash is same in magnitude, but not in sense. That means angle is 30 degrees, but at P 30 degrees is anti-clockwise direction and at P dash some and clockwise direction, not in sense. Then the transformation is called isogonal transformation. Transformation is called isogonal transformation. Now, what is the condition? Actually, there is a theorem for to identify whether the given mapping is conformal or not. What is that? If f of z, the function f of z is analytic, f of z is analytic, and f dash z is not equal to 0, means what? Derivative is not equal to 0 in a region. It is never 0 in the given region R of what? Of z plane. Z plane means contains xy coordinates of z plane. Then the mapping or the function, then the mapping, what is the mapping? W equal to f of z. W equal to f of z is conformal. This is the theorem. So to check whether the given transformation W equal to f of z is conformal or not, what is the condition? It must be, function must be analytic and f dash z not equal to 0 at all points of R. At all points of R. Okay. Now, this is about conformal mapping. Now, in this conformal mapping, there are some standard transformations are there. Okay. Just I will give briefly some standard transformations. Some standard transformations. Okay. What is a standard transformation? First one is translation. Translation. What is a modal translation? W equal to z plus c. W equal to z plus c. Okay. Nothing but W equal to f of z. What is f of z here? Z plus c. And c is complex constant. What is c here? Complex constant. So how it behaves? See, W equal to z plus c. What is this? Is W is nothing but what? U plus iv. Z is nothing but what? X plus iy. C is nothing but what? IC1 plus IC2. So if I equate real and imaginary parts, I will get X plus C1 and V equal to what? Y plus C2. V equal to Y plus C2. Done. Okay. For example, see, for example, just to get the idea how transformation behaves. How transformation behaves. For example, W equal to Z plus some 1 minus 2i. Okay. Then Z equal to 1 minus 2i. You take some points on this one also, doesn't matter. Okay. That is U plus IV equal to X plus IY plus 1 minus 2i. Therefore, what is U equal to? X plus 1. And what is V equal to? Y minus 2. This implies what is X equal to? U minus 1. Okay. And no need of this. No need of this. Okay. For example, in this plane, if I consider this is 1 point 0 comma 0 O, and this is 1 point 1 comma 0, and this is I will take 2 comma 1. This is the point. Okay. X plane and Y plane. That is nothing but Z plane. That is nothing but Z plane. And another point is 0 comma 1. If I consider this one, this rectangle, this is the region R. Corresponding to this, then at 0 comma 0, what is U value? U value 1 and V value minus 2. Then at 0 comma 0, UV value. So O 0 comma 0 is mapped to what? 1 comma minus 2. Right? Next one at 1 comma 0. U equal to what? 1 comma 0 means 1 plus 1 using this one. Okay. And V equal to what? 0 minus 2. That is negative 2. That is negative 2. Therefore, 1 comma 1 0 point A. I will take this. This is B and this is Z. Therefore, B is mapped to what? This is I will take some another point, something O dash I will take. Okay. This is mapped to what? 2 comma minus 2. Similarly, what is this point C? 2 comma 1 is mapped to what? U value is what? X plus 1. That is 2 plus 1, 3. And V value is what? V value is what? 1 minus 2. Is it correct? Y minus 2. Right. 1 minus 2 means minus 1. So what is the corresponding point here? 3 comma minus 1. This one. Similar D. 0 comma 1. What is this is then? U equal to x plus 1. This is 1. Next one, v equal to what? V value y minus 2. That is negative 1. So d 0 comma 1 map to, this is c dash I will take. Map to d dash 1 comma minus 1. So what are the points now here? I will draw. Okay, I will draw here. The next figure is in UV plane. This is U and this is V, W plane. This is W plane. And what are the points required? The first, this is D dash 1 comma minus 1. If I take this as 1, this is 0 comma 0, 1 comma minus 1. This is negative 1. So this is the point D dash. What is the next point? C dash 3 comma minus 1. Somewhere 3 I will take. 3 comma minus 1. This is the point C dash. Next point is what? 1 comma 0 map to 2 comma minus 2. Where is 2 comma minus 2? This is 2 I will take, and this is minus 2 I will take. Okay, then 2 comma minus 2 means this is the point 2 comma minus 2, and the last point is this is what? B dash, right? This is D dash. And next one, what is this point? O point. I will take some, this is some E dash. Okay, 1 comma minus 2. Where is that 1 comma minus 2? Here, 1 comma minus 2. This is the point E dash. 1 comma minus 2, 2 comma minus 2, this one. So what is this? Join all these points. This is the rectangle. So translated. This is the I think this first figure is wrong. 1 comma, this is, sorry, all of you. This is, yeah, this is 0 comma 2. Done. This is 2 comma 1. Where is this point? 1 comma, this is 1 comma 2. All of you, that's the mistake. 1 comma 2. So which point? B 1 comma 2. B 1 comma 2 means what? This is 2 minus 2. This is 0 becomes. This is 2 comma 0. 2 comma 0. So B dash value is what? 2 comma 0. That is the change here. So I will change that point. B dash value 2 comma 0. So let me draw clearly. Now this is the U axis, and what are the required points here? One by one, let me write from beginning. First point is 1 comma 0 comma 0. 0 comma 0 means 1 comma minus 2. 1 comma minus 2, 2 comma 0. This is 1. 1 comma minus 2. This is the point E dash. 1 comma minus 2. Next one, 2 comma 0. 2 comma 0 means this is the point. That is B dash. This is 2 comma 0. This point is 2. Done. And next point is what? C dash 3 comma minus 1. This is 3. If I take 3, 3 comma minus 1. This is 3 comma minus 1. Next point is what? 1 comma minus 1. 1 comma minus 1. This is D dash. Okay. Now join all these points. This one and this one and this one and this one. Translated. That means the rectangle. This is R dash. That means whatever the rectangle position is here, it is translated to here. In the first quadrant it is there. In the first quadrant it is shifted to what? Fourth quadrant. Just I'm giving a rough example, this one. Okay, you can make it clear. That is called, that is why therefore the complex function W equal to f of z is called transformation. Generally is called transformation or mapping. Transformation or mapping. Okay, it is also function, but what is that originally represents? It represents a transformation or mapping. Now coming to another translation, another one, second one is translation is over rotation and magnification. Rotation and magnification. What is the type of this one? W equal to Cz, where C is complex constant. Where C is complex constant, right? Okay. And here when C is, for example, let me take, for example, when C is real, sub W equal to Cz is magnification. And when C is pure complex, When C is pure complex, W equal to CZ represents rotation and magnification. Rotation and magnification. Okay, right? Okay. And next one. Third one is inversion. Third one is inversion. And what is this one? Obviously, W inverse means W equal to 1 by Z. W equal to 1 by Z. It represents inversion. And the fourth one is bilinear transformation. This is important. All of you, this is important. Bilinear transformation. Bilinear transformation. Now, see, what is bilinear transformation? It is a transformation of the form, a transformation of the form, a transformation of the form W equal to AZ plus B by CZ plus D. W equal to f of Z. And what is the f of Z structure? AZ plus B by CZ plus D, where A, B, C, D are complex constants. Are complex constants. A, B, C, D are complex constants. And another condition is what? AD minus BC not equal to 0 is called bilinear transformation. Is called bilinear or Mobius transformation. Mobius transformation. Bilinear transformation or Mobius transformation. Okay. Actually, Mobius transformation is bilinear, not conformal. Okay. I told Mobius transformation in conformal. Conformal means it's conformal. That's it. Bilinear transformation, or it is also named as Mobius transformation. And why it is called bilinear? Why it is called bilinear? See, equation 1 is clearly linear in Z, correct? Linear in Z. What is Z power? What is Z power? 1 only. Okay, so it is linear in Z. Now, 1 can be written as, let us take cross multiplication and write the expression for Z like W. Then what you will get? dW plus B by CW minus A, which is linear in W. Therefore, equation 1 is linear in both Z and W. That is why it is called bilinear. That is why it is called bilinear transformation. Bilinear transformation. And see, in bilinear transformation, all are there. In the bilinear, you say. The bilinear transformation is the combination of all previous transformations, is the combination of translation, right? Translation means what? AZ plus B. Exactly, it is here. W equal to AZ plus B. This is translation, right? And just AZ. AZ means what? Magnification or rotation. Translation, magnification, rotation, and inversion. By Z is there. Okay. And inversion. So bilinear transformation is combination of all the previous transformations. Okay. And one more point. Okay, let me finish first. Let us find bilinear transformation. And one more point is, you take yeah, take the cross ratio principle. This is important. The cross ratio principle I will write here. Cross ratio principle in bilinear transformation. Cross ratio principle in bilinear transformation. Okay, what is that? If W1, W2, W3 are the W1, W2, W3 are the respective are the respective images of W1, W2, W3 and W4. 4 points are there, and W4 respective images of Z1, Z2, Z3 and Z4. W1, W3, W4 are the points in the W plane. Z1, Z2, Z3 and Z4 are the points in the Z plane, are the points in the Z plane. Okay. Then what is the cross ratio here? W1 minus W3, W2 minus W4 by W1 minus W4, W2 minus W3 W3 equal to this is Z1. Just replace W's by Z, that's it. Z1 minus Z3, Z2 minus Z4 whole by Z1 minus Z4, Z2 minus Z3. This is the cross ratio principle. That means it is invariant under the bilinear transformation. Cross ratio is invariant under the bilinear transformation. Invariant under the bilinear transformation. Then see W1, W2. See here, you remember this part. You remember this part only. You remember this part. This principle you remember. Okay. Just we replace W's by Z's here. That's it. You can remember this principle. Now, let me solve one problem based on how to find bilinear transformation. Say one problem. Find, first question, find the bilinear transformation. Find the bilinear transformation that maps the points 0, 1, I in Z plane onto the points 1 plus I, minus I, 2 minus I in the Z plane. Okay. Then solution. Solution is just wait. Some mistake is gone. What happened? Give me a minute. Some problem is here. Yeah. Now, where is it? Yeah, this is the problem. Solution. First, what are the points on the Z plane? Z planes are let Z1 equal to, first point, see, Z1 equal to 0. These are the points in the Z plane. Z2 equal to 1, Z3 equal to I. And Z4 point is not there. Always put Z4 equal to Z. And W1 equal to 1 plus I, W2 equal to minus I, W3 equal to 2 minus I. These are the points on the W plane, and W4 equal to W, and W4 equal to W. Now write the cross ratio principle. The cross ratio principle is, and one more important point for you is, what I have written cross ratio principle, W1 minus W3. One can write in a similar way. Not only this, or I will write here, or you can write W1 minus W2. According to that, you change on the right side. That's it. W1 minus W2. W3 minus W4. It is a sequence. W1, 2, 3, 4. By, you can write W1 minus W4, and next one W3 minus W2, W3 minus W2. Same as it is, just replace W's by Z, Z3 minus Z4, whole by Z1 minus Z4, next Z3 minus Z2. Okay, I will use this principle better. This is the principle, is sequence to remember. So I will write the cross ratio principle is what? W1 minus W2, W3 minus W4. Okay, and here W1, and here I will interchange W2 and W4. W3 minus W, what is this? 2. W3 minus W2. According to the, just replace W by Z. Z3 minus Z4 by Z1 minus Z4, Z3 minus Z2. Now let me substitute one by one. What is W1 here? W1 is here 1 plus I. So 1 plus I minus W2, minus I plus I. Done. W3 2 minus I, and W4 W by W1 1 plus I minus W4, that is W. Next W3 2 minus I minus W2, that means plus I, equal to. Coming to Z terms. What is the Z1? What is the Z1? What is the Z1? 0. 0 minus what is Z2 value? 1. Next, Z3 value is what? I. Z4 value Z. And this is 0 minus Z. Z3 value I minus Z2. Z2 value is what? 1. Got it? Now, let me simplify this. What is this? Becomes 1 plus 2I. Next one, 2 minus I minus W whole by 1 plus I minus W. And this is what? Just 2. Just 2 equal to, this is minus 1. And this is I minus 1. So I will write like this, I minus 1 into I minus Z by, minus minus gets cancelled. Now Z will be there. Z will be there. Now, how to simplify this? I will write this is 2 minus I minus W by 1 plus I minus W equal to. Let us take the remaining terms to this side. So what is this? Is 2 into I minus 1 by I minus Z by Z. What are the terms here? I will get here 1 plus 2I. Is it correct? 2 comes here and 1 plus 2I comes to here. Done? Okay. Now, this is 2 minus I minus W by 1 plus I minus W equal to, let us rationalize this. If I rationalize this, what I will get here? Let me take I minus 1 into 1 minus 2I by 1 plus 2I into 1 minus 2I, 1 minus 4, 1 plus 4, 5 I will get, I think, right? Right? Okay. Done. So what is this part? This is I minus 2 means plus 2 becomes, this is minus 1, and this is plus 2I by 5. This is 3I plus 1. That's it. Okay. So 2 into what I will get? 3I plus 1 by 5 by rationalizing. Okay. Into I minus Z by Z. I minus Z by Z. Now, how to solve this? So I have to get W equal to something. So I'm taking cross multiplication. 2 minus I minus W equal to 2 into 3I plus 1. 1 minus 1 plus I minus W I minus z, I minus z. That's it. Okay, phi z comes here. So after simplification, what I'm getting in terms of take w entire this side, 6i plus 2, 1 plus I minus z minus 2 minus I into phi z whole by minus phi z plus 6i plus 2 into I minus z. Okay, that is equal to w equal to z into 6 plus 3i plus 8 plus 4i whole by z into 7 plus 6i plus 6 minus 2i. Okay, is the bilinear transformation. Is the bilinear transformation. What is this form? W equal to AZ plus B by CZ plus D. Here, what is A value, B value, C value, D value? Clearly, AZ plus B by CZ plus D. This is one problem. Okay, right? Next one. Similarly, you can solve the remaining problems. Let me try to check. That's it, enough. I have to give some more problems. Okay, I will solve some more problems and I will put PDF for you. Okay, this is about bilinear transformation. Let me check, some more problems are there. Okay, I will stop here. This is about bilinear transformation, important topic. Remember the cross ratio principle and solve it. And actually, if the procedure is big one, this multiplication, cross multiplication, one can use compound into dividend rule. Compound into dividend rule. I will apply that and I will solve two more problems for you. Okay, I will post it.